we'll keep an eye. Good morning, ja. How was the weekend? Schön.
Short man.
Short. Short. Long. Kurz. Gotta test my German knowledge. German vocabulary. Short. Yes. Well, after last week, it's 33% shorter. So, sorry. Terrible. Or you could view it as last weekend as 50% longer, and then realize this is one, and then not feel so bad about it, maybe potentially. So, third project, decent?
Yeah.
Pushing F9, letting things do what they gotta do. Yeah, the great part about that, the idea of simulations, you're gonna be doing this. If you take me for 244, we'll do it all at 244 again, is that it allows you to answer questions that you can't answer otherwise. That's what's so cool about it. Like, the one about poker, like if you're sitting, what, 3 from the dealer, 3 right of the dealer, and it's on the river draw, what's the chance of getting it, whatever the hell it was. And you'll hear poker players say things like, oh, it's 1 in 200, or it's 1 in 500. And I'm like, well, how do you know that? And the reason they know it is because they've essentially done that. They've played so many poker games, and not just them, but whoever tracks those kind. Have you ever looked at poker probabilities online? Poker hands, like what beats what in a game of poker? 4 of a kind beats, or a full house beats 2 pair, or a full house beats 4 of a kind, all that stuff. And it's all based on mathematics. And you can calculate those probabilities, but they're kind of dumb the way they're calculated. For example, I was doing CrossFit about a year ago. We did a deck of doom, and we had assigned. So a deck of doom, we take a deck of cards, pick 4 exercises, and each one of the suits of a deck of cards is an exercise. So you take a card, throw it down, and that card tells you what exercise and how many to do. We make aces be, I think, 14, kings are 13, queens are 12, jacks are 11, 10, 9, 8, down to 2. We had picked hearts for pull-ups, and then we proceeded in 4 cards to pull 4 of the 5 cards of a heart royal flush. And then everybody else is screaming, oh my God, I'm screaming, holy shit, what's the 5th card gonna be? I'm so excited, because you never get a royal flush. Because how often does a royal flush happen? Well, it happens once in, I think it's 1/3 of a million hands or something like that. You can calculate it. As you saw in that project, you can actually calculate that. But it's dumb to calculate it, because I've never seen math excitement evacuate a person more quickly than when you make them calculate poker probabilities. It's way more interesting to let you do that kind of a simulation and let the thing build itself around it and actually see the results. And then once you have it, you can be like, oh, okay. I helped, a buddy of mine is teaching 245 right now, but some of you guys may have to take 245 at some point, some of you business majors. And 245, part of that is actually calculating poker probabilities. And I always ask, why do you do that? Why do you, because it's in the curriculum. Like, why is it in the curriculum? Especially for a business major. And because it's called super counting, just like your project was. But the way this approaches super counting is the way the world approaches super counting, which is via simulations. And it's great because it allows you to model all kinds of cool things. I took a multiple choice exam, CPR certification class, about 3 months ago with my buddy Jenny Cruikshank, she's rad. And the final exam was 25 multiple choice, A through D. And as I was filling it out, I knew I was doing pretty well because I'm kind of a dork for these kinds of like standardized CPR, American Heart Association tests. The answers are like A, B, 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 A, B, 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 C, 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 B, B. And I'm looking around the room going, these kids are gonna be freaking out, and they're all like sweating bullets. And Jenny's already told us once, if you get anything wrong on this exam, you don't pass. You have to get a 25 out of 25 on it. And I'm watching the kids and they're sweating bullets, and I'm thinking to myself, I wonder if they did that intentionally to make you second guess yourself. So I wanted to test it mathematically. Could you test that mathematically and say there are not enough jumps to be random? Because you would think if they made the test randomly, you know there'd be clusters, of course you know there'd be clusters. But how many clusters would you have to be random? And that is a question you cannot answer directly. So what I did was, I invented an Excel spreadsheet, so I pushed down F9, and let it generate 25 question multiple choice exams and graphed what happens. On average, you should have 17 out of 25. There you go, 17 clusters. So AA, BBB, CC, DDDDDDD, you have 17 of those on average. That's the average of the distribution. How? I have no freaking idea. I don't know what the hell it is, but that's what the average is.
When I came back to school, I actually looked up test-taking strategies, and I read a story. I think it was a Harvard professor who made a question, or like a 50. It was all A.
Just a
yes. Exactly.
Totally probable. Excuse me. Totally possible, not probable. Yes. I mean, if you're generating random numbers, that's totally fine. But, I mean, it's just one of those things, how many, so that's the extreme case, yes?
Yeah.
The other extreme case is A, B, C, D, A, B, C, D, A, B, C, D, which is also would be equally unlikely. So you have to have some clusters somewhere, but the question is how many clusters between that and this other ridiculous one. And there, 17 on average. So, as it turns out, mine had 11 clusters, which was too few, but not statistically too few. It was just on the cusp of starting to get a little bit unreasonable. So it was kind of cool, it was fun. That's the kind of question you can't answer directly. I did about an hour of Googling. I'm like, the hell with this. There's no distribution. I'll make up my own. Named that after my wife. It's like, this is all good. Yeah, Katie.
So, I emailed you. I have Excel 2010.
Yes.
And my F9 button just wasn't.
Oh, I got your email. I said just come and do it at school.
Oh, okay.
Yeah. Without being at your computer, I can't fix it.
Okay.
I probably can fix it sitting at your computer, but I can't fix it without.
Okay.
So I just said come and do it at school. And then you got a rating and coupon, which is perfect.
I did it, but I pressed something that changed the numbers. I don't know if it was the right something.
If it was changing them, they're changing randomly because the way I set it up was random number generation. If you were changing them, they were changing fine.
Okay.
They weren't changing, it's fine. Totally good. Cool?
Yeah.
Very good. Anyway, that's why I like that project. It's kind of a nod to the future. The beginning of it is kind of a nod to the past because you're just counting. You're literally counting, super counting by not counting 1, 2, 3, 4, but you're counting. How many years would it take that supercomputer to crack your banner code worst case scenario? What was it? What it ended up being?
27 million.
How many millions?
Like 27.
Oh, something ridiculous, yeah. Some ridiculous amount of time. Good, thank you, Renee. Very nice. So do you feel better about your PIN? Feel pretty good about your PIN? Yeah, I actually sent the results of this to IT, thanking them. And they were confused by it. Which made me a little bit surprised, actually, because they're geeks like I am. But I talk to the IT department frequently about things like spam email, numbers of spams, the RAID drive configuration for your last project, because that's a perfect example of this stuff in action. Your spam filter, which your last project deals with false positives and false negatives, which again is something that most books don't touch on too much, which is kind of a bummer, I think. So I designed a project to get in there, because false positives and false negatives are things you should be concerned with. And spam is probably the easiest way to kind of think about false positives and false negatives. Right? A positive test result would be if you're taking a test for, say, a disease, like Lyme. I've had Lyme disease like 4 times.
Oh gosh.
I know, it's great, awesome. And you want to find out if you have it or not, and you go to the doctor and they take blood and they run it through some kind of a centrifuge and it comes back positive. That means the test thinks I have Lyme disease.
Right.
Okay? Do you get nervous?
Yes.
Maybe, because it could be a false positive. And this is why I love the fact you said yes, that makes me happy.
I've had a false positive and had to go through consistent tests.
But what we're going to do is we're going to analyze the false positive rate. That's the kicker.
Yeah.
Here's the thing. Here's the thing that blows people's minds. Marilyn Voss-Savant, she used to have a column called Ask Marilyn. She might still have it, I'm not sure. She's apparently the world's smartest individual. She has an IQ of 125 or something, which is off the charts smart. And she was asked a question once about false positives and false negatives. And she answered it correctly. And it made people, including statisticians, go, you're wrong, you're wrong, you're wrong. This is how you actually do it. And she's like, no, actually, I'm right. And here's why I'm right. And it's amazing that even statisticians were getting the math wrong. And that frustrated the hell out of me. So then, as I started paying attention to people and how they were interacting with the idea of a positive or a negative test result, people are always believing positive and negative test results. But they could be falsely positive or falsely negative. It's like when I go to the doctor, like I do once a year now, that I'm of the age, you go to the doctor once a year, I got a blood panel done. It's about 20 or 25 tests. And the last time I went, one of them came back positive. It was for my thyroid. They said my thyroid was hypothyroidic, was underactive. The doctor started, Danny's shaking her head, Madeline's like, if you know anything about thyroid, I am just about as far from hypothyroidic as you can imagine.
Totally.
The week before, I had to ride my bike to Broken Top, climb Broken Top, and ride home in order to tire myself out enough to sleep. If anything, I'm hyperthyroidic. If anything, and that's probably believable. So the doctor's saying, okay, you're hypothyroid, so we should get you on a range of medicines right now. I'm like, or we test again in like 3 months and see if the results come back conflicting. Or you look at my body, or you look at what I just described to you, and you took it all, you see what I'm saying?
Yeah.
The problem when a medical professional is ready to prescribe drugs based on a potential false positive, that's when I get nervous, and that's when I say the world needs to know more about these things. Hence your last project, which you will never find in any stat textbook. But is the math that allowed me to calm my neighbor across the street down when she tested positive for an amnio exam for Down syndrome for her baby. And she was freaking out. And I was like, sit down, let's do some math together. First time in history, math calms somebody down, just so you know. Adeline is perfectly healthy, and you'll do the math that I did with her in your project. It's pretty amazing stuff. Pretty amazing stuff. Not much math, as like everything else in this class, but wickedly powerful math. So no Excel component for that one either, which is different than the other projects so far, at least this project, and your out-of-class exams. But pretty powerful stuff, and it helps you understand what a false positive is and what it can imply. So, cool. All right. So that's not due until week 10. You got plenty of time for that one. Don't wait till the last minute, but you got time. There's not a whole lot of math. Really, the way I teach this one, you can use it. You can do it formulaically. But as you've seen in this class, I take all the formulas that I possibly can in this class and remove them and just go with straightforward kind of context, and that's what that project does. So the only work you have to do in that project is show me how to set up a 2x2 contingency table, which is how you dealt with those in the first two projects you guys did, where you're putting numbers in cells and you're summing up and you're going diagonally, and so you'll just do that. You'll see it. It's one more 10-page document from me because I type like I talk. What else? This week! We got both parts of the exam, yes? Mm-hmm. So we got the in-class part. What's on the in-class part? Yes, on Wednesday. What's on it? Relative position, absolutely. Outliers, a smidge of outliers. I'll give you more information about that in a second. And last but not least, probability distributions. I saw some of you guys working on the out-of-class today. Fantastic. Love that you're working together. That is way more involved than anything you'll see on Wednesday in class. Wednesday in class I can give you right now. I think I told you this already. I'm going to give you a t-table with a probability missing. Your job, first job, is to tell me what goes in that part that's missing. Then find the average and standard deviation of the distribution. That's all you have to do on Wednesday in class. The stuff you're doing in Excel is way more interesting, but also way more frustrating from a time perspective, time standpoint. So, as far as outliers go, the only outlier question I put on the in-class, because I realize the outlier question on the out-of-class is a real nice, deep one. I mean, it's a huge chunk of points, and it's a nice one because it forces you to think about which method you want to use. The only one I put on the in-class part was you have two data sets that you're going to be pulling percentiles out of. So, a bunch of numbers, what's the 40th percentile, what's the 80th percentile, things like that. And then I ask you, are there any outliers in either of those data sets? And I say, pretty simply, just use the Iqr method. And the reason I tell you that is you can just graph it on your TI, and it'll tell you if there's one or not. So you just run a modified box plot, and if there's an outlier, it'll pop up. Then you just write that down. So real straightforward as far as that goes. Cool. And then find some percentiles. Ching, call it a day. Cool. Real straightforward. You guys have worked, you all right? It's week 8. It's week 8. Yeah, it's week 8. So I try to make this in class real nice and user-friendly. So it should be. The out-of-class is a pain in the ass enough. I know Sean is a pain in the ass enough. So the in-class, try to counter that. So on average, you're okay. Please, Tim.
Didn't you say that out-of-class is due on Friday? Or?
I had it due on Wednesday, but the people were saying that there's so much due on Wednesday, you might need extra days. If you need more time, Brandon, let's make it Thursday, because Friday's going to be a zoo. I still got it due on Wednesday. But if you need an extra day, just bring it in Thursday. That's fine too. I got no problem with Thursday. Friday's going to be a zoo, and I won't pick it up until Monday, and I don't want to wait that long to get it graded and back to you.
Doing the out-of-class, will that help for the in-class?
It can't hurt. I don't know if it'll help. I can only imagine it would help because you'd just be immersing yourself more in the definition of like percentile and things like that in a box plot and outliers. So I can't imagine. It definitely won't hurt. It's hard to measure if it would actually better your understanding, but it definitely cannot hurt. I promise you that. Is that fair? Yeah. And what we're going to do in class today won't hurt either, because we're going to be making. We already started this with the chickens. We were creating distributions around my chicken flock. Mm-hmm. We're going to do more of that today, and we're also going to talk about Max some more and distributions around him. So once again, dealing with distributions and finding averages of them is what's on your exam. It's not like we're going to stop talking about that once the exam's over. That's the rest of the course, is finding averages of distributions. So doing more of them through the context or through the lens of binomial doesn't make it more confusing, it just makes us do more of them. Ready to ask me that question? Or do you not have a question? I'm sorry, I jumped.
Oh,
Go ahead.
I'll ask it later.
Are you sure?
Yeah.
Okay. Anything else? What do you got?
What days are final on?
I don't know. I put it on the schedule page.
Wednesday?
Wednesday?
Yeah.
And remember, it's not a final. It's just your last exam. It's just your last. It's just like the other two. And I'm going to send. At some point, class evals go out relatively soon. They may have already started going out. Would you guys be opposed if I sent you a SurveyMonkey survey in addition to the class evals? There's a couple specific questions I want to ask you guys about assessment. Like, for example, I really, really, really want to stop giving you class exams. That's not to paint your responses at all. Just that's my gut. I hate watching you guys take them. I know how worked up you get, although you're getting worked up less, I've noticed, I think, because you understand that I'm not out to trick you, I'm just out to assess your learning. At the same time, I'd like to stop giving them because they're archaic and they're historically tied to a British system that
is kind of obviously a little bit dated.
So I'd like to eventually move away to a strictly out-of-class type assessment thing, but I want to get your guys' input on that before I just do it. I've tried this for 2 years, and I told you the responses. It comes back split, where half the class likes it and half the class doesn't like it. I'm like, so I'm looking for clarity, and I'm not trying to steer your, probably just did by telling you that, but don't tell me what I want to hear, tell me what you think. If you think the in-class exams are a good idea, then tell me that. I want to know. I'm trying to collect data to see how my students feel about the assessments, how you feel about the projects, the quizzes being optional, the in-class quizzes versus the out-of-class quizzes, the rainy day coupons. I want to know about all those pieces of assessment because I want to know how to design the course so that you learn most effectively, right? Does that make sense? Mm-hmm. So I think I have to make a SurveyMonkey survey because I think the evals have already gone out, or at least they're already done and ready to go out, so I can't add questions to them. I'll make it worth a quiz or something. That way you'll be incentivized to do it. Yeah. Anyway, blah blah blah. Cool. Mm-hmm. Ready for Wednesday? Mm-hmm. Hell yeah, you're gonna crush. Is that thing still recording? This thing was acting up last class.
Yes, it is.
It is. Thank you, Christina. Awesome. Okay. So relative position. A little bit of outliers, smidge of outliers on the in-class, and some probability distributions. And we'll do some more distributions today with the chickens. That'll just be more review for that idea.
And he was talking about you're okay with Thursday?
Thursday's fine. Yeah, if you need, I understand there's a bunch going. There's also, I think I posted a quiz too. Oh, the quiz for this week is, did I tell you guys what I was going to do? I finished one of the homework problems from the probability distributions.
E2.
It's E2, exactly. It's one of the ones then you would ask for E1 and E2. And actually, you asked for E2, we did E1, and then started E2. And I figured this is a perfect time to try out an idea that I've had, which is to have you guys turn in homework instead of doing quizzes. Just have you use the homework you've already done and submit that, instead of doing that and then also doing quiz. This is kind of like a try for me to see how this goes. Plus it gives you guys points, so yay, win-win. Please, Madeline.
You told us kind of what to expect on the test for probability distribution.
Yes, ma'am.
Outliers. What about relative position?
Relative position, make sure you can calculate percentiles.
And that's it?
Straightforward, either from a raw set of data or from verbiage.
Okay.
You know, like if I say to you, for example, that, I just read this one. Oh, it was about gamers and I've lost it, and I'm gonna make it up. 60% of gamers in the United States are under 50 years of age. Right? I've just given you the 60th percentile, which is 50. Because 60% of gamers are under 50 years of age. Boom, 50 years of age, 60% of the data are less than that. Boom, P60. See that? No data set needed. I've given it to you verbally. And there's a couple of homework problems like that where we talked about smoking and weight gain, I think it was. So, but be able to do that, be able to pull them off of a data set, which is really straightforward, just kind of count. And then I think, I'm trying to think back, I made this thing a while ago now. I got some box plots where they're already made for you, and your job is to go in and pick pieces off the plot, like the quartiles, the medians. So just know what a box plot is and know what the pieces of it are.
And in the rare event, we're actually calculating the percentiles.
You don't have
Formula
to.
One. Okay.
There's no formal definition of it. That's what part of the out of class, right? Is looking at the different definitions and realizing that they're essentially the same anyway. So what I do, they are essentially the same, especially when the data sets get large. What I'm doing when I'll grade these is I'll understand that, and I know that I'll be getting a range of answers. Does that make sense? So if you've got a data set where this is the smallest data point and this is the largest data point, and I ask for the 80th percentile, I'm looking for numbers that are around here. I'll know that if you're giving me a number down here, you don't know what 80th percentile is. So that's what I mean. Logically, I know where to draw from. Please. There's a safety pin. That's okay. I got my tetanus shot, but I'm going to pick it up. Thank you. Namaste. Cool? Good. Good questions. Good question about the percentiles, yeah. It's probably a little bit percentile heavy, a smidge, only because the outer class is more outlier distribution heavy. So I try to balance it a little bit to get a little bit of each thing. So, and the percentiles seem the easiest way, the easiest thing to put more of on the in class because it's the least mathematical of the three of them. Does that make sense?
Mm-hmm.
At least jargony, at least mathematically. So I figured that would hurt the least on your assessment in class. Cool. All right, fantastic. All right, let's chit chat.